So today we are going to see today questions of LeetCode. So let's begin from here. So the question be given today is 1519. So we have to find the number of nodes in the subtree with the same level, right? So read the question from here. So it is saying if you are given a tree, uh, you are given a tree and it is connected, right? Connected on directed graph and has no cycle. Connected means all nodes should be connected. Yeah. So you can see the example one in which we see all the nodes are connected with each other. Undirected, there is no direction between the one node to another one and has no cycle, right? So it is not maintaining any cycle in this. Now we have saying that consisting of n nodes, right? A number from 0 to n minus 1. N minus 1, that's good, and exactly n minus 1 is this means it is not making any cycle and is not connected with, it is fully connected. Yeah, now we can say that the root of the tree is node 0, in which we can see that each node has a level, right, given. So root node is 0, this one root node is 0, and has this one, we're talking about this one, and which has a lower case character given in a string levels, right? The number of the nodes with the number I is a okay. What is saying that all the nodes is given with its level in the small character a. Like if we'll talk about this node, right? So it has a level what, a small a, right? And similarly b c d we have given. Now it is saying the ages array is given in the form of age between two nodes, right, which is ai bi. So this is the node maintaining the tree. Now what we have to do, we have to return the size of the n, where answer of I is the number of nodes in the subtree uh, of the ith node which have the same level. Okay, okay, got it. Means if the level is same, right? So we have to count the that one in the array, right? So we have to maintain the number of arrays, right? Number of counts you can say in the array. So it is saying this. Let's suppose tree is consisting of nodes in the descendant nodes. Gotcha. It means let see the example one in which it is saying that this node is given and 2 is also given, right? So it has the same level of this node and this node has the same level, right? So if we will say that these two have the same level, why we have the same level? Node 0 and node 2 we can say that same level because it has leveled with a and a, right? So if we'll count this one, so how many is this? 1 and 1, it is total 2 we have, right? 2. Next, if we'll talk about after 1 0 we have 1, right? This one. So 1 is have level b, so we can find the b in another position, right? So we don't have any other node that is connected with b and that has what, level b. It is independent node we have. It is connected but it is independent, right? It is connected but it is independent. We don't have the same level, so we have to treat like this is level 1 we have, this is the separate level we have, so each one is separate level. Similarly for this one and this one, right, we can say its level are what, different levels we have because they are not maintaining. But if we'll talk about the uh, node 0 and node 2, they maintains its level. Okay, so let's continue the another example, right? So in this we can say that this node contains what, a b, uh, node 0 contains b as a level, 1 contain b and 2 is also containing b and 3 is also containing b. So if we'll talk about this r or the same level, so this will contain what, it will be 4 initially. Node first is what we have, level 4, right? 4 count we have. And next if we'll talk about uh, this one, right, this one, so it has level same, right? This is also a subtree, so it is have 2. And if we'll go to this one, right, so this is also contain only one count. So for this, right, how many subtree we have? We have one, this one, right? And this is also, right? So total 4 we have. If we'll go to this one, so we have total how, 2, this one and this one. But when we go to this node, how many we have? Only one node we have. Similarly for this node we have only one. Okay, and that's why we have the we can say this will be our output we'll get, right? So for the previous one, if we'll talk about the this output, right? So starting we have what for this subtree we have a and a, right? So it will go to 2 and rest of it will come what 1 1 1. So all total 7 we have to return like this, okay, as output, and this is like that. Let's see another example. We have given what a given, right? And this is also the same level. So these two these three maintains same level because name is same, right? So if we'll go to this level, how many we have? We have this one, and this one. Three we have, right? Three nodes we have the same level. So this will come three. When we come to this level, how many we have now? Now we have two, this one and this one. So it will come two node have the same level. And if we'll check for this one, right? So these are on the same level, but it is not subtree, right? These are, if you do like subtree, this is not subtree. So this is separate subtree. This is T1 and this is our T2 separate, and that's why we will say that we'll pass 1 and 1 and 1. So that's all, and this, right, 3. So this is our output. So let's go to the browser and let's write code. Okay, so this is given our what number of nodes we have given, edges we have given, and levels we have given. Okay, so what we should do first of all, we have to maintain our adjacent list, right? So I'll take adjacency list. Okay, and this is what we can say, we will make a map, right? Has map like this, right? And this type should be, this is the map, right? So what we'll do, we'll say map, and this will take map. And map of what? We have some node, right? So that is a list of node. We have given integer n, and all node, like at node 0 we have a list of integer, right? So we'll take list of nodes we have, neighbor nodes we have, you can say. Okay, so this is our urgency list. We have it. Now what we have to do, we have to initialize our list. For that, what we have to do, we will go for all the edges, right? These edges we have, so for each edges we will move, right? So if we'll talk about, this is integer, right? And we'll do one by one, we'll get. So for all edges we will go for the loop, right? Then we'll take node a, and this node is what, is at what, 0. Node a int node b. Okay, and this is what, is at 1. So now for each node, each edge, we will have the combination of its two nodes, right? So two edges we have got it, right? Now what we have to do, we will add on to the adjacency list, right? So this is our adjacency list. So what we should do, we should add on, we'll check if absent, then we'll add on to here. So we'll pass what, this node we have, node a we have, and we will pass the value, and and it will map to what, the list of all the array list, all the list of neighbors, right? List of all its, we can say, nodes or neighbors, right? For all node, right, it has a list of what we can say, uh, neighbors, right? And that is what, node b, suppose. And similarly, I'll do copy paste. Yeah, so this will be our b, and study program, we have the same program, same type of program we have. Okay, now if we'll go to int answer, right? So this answer will contain what, new int, and this is n, right? The size will come from what, the number of nodes we will have, right? Total answer we have to return as a number of nodes we have to return, right? So how many nodes we have, at that time, we will return their subtree numbers, subtree nodes numbers. Now we'll take levels. Levels is already we have given in the string. So what we will do, we will take levels, right, with the levels we have given, and 2 char array, and we will get into the array form. All the character will come in the level, or this better we will say levels array, we can say levels array, we can say, okay, levels array will say. Now it will do DFS utility, right? DFS utility, we have a DFS utility method that will traverse all the its node, right? So I'll start from node 0. Node 0 doesn't have any parents, right? So that will take -1, and then what we will take, we will take adjacency list that we have created, and then we'll take the level that we have created, levels array, and then we'll do answer, we'll pass answer, right? And we'll update our answer by doing the recursive call of DFS, right? And then we will return what? Answer. Okay, so these things has been done, right? I think you have understood. So let's go and do some hands-on with the DFS utility, right? So this DFS utility method we have created already. How? In the previous example, previous last day example, right? Last day problem solution. So how we will do that? We'll do public, and it will return a set of integers that is called array. This is our starting node, so it will take node, right? And this is -1 is parent, so we'll take int parent, and this adjacency list, you know that what we have taken, the map of this, right? So this adjacency we can say oh, map of integer we have, right? So I can copy this one from here to here, and we'll pass here. Okay, now levels you already know, this is your char array, right? So you can pass here at the char array. Answer you already know, this is your answer we have added, right? All are mapped here. Now what we have to do, we have to store count of all the alphabets from the subtree, right? So how we'll do that? We'll take int array, right, array type, and then we will say all node count we have to return, all node count we have to return, and this is what we have to take in the we can say new int 26 letters we have, right? So how we'll do that? This node count we have, and this will contain what at the levels array, right? At levels array we have, right? And this will take at each node have some levels, right? If we'll do the with the single character do a, right? So it will result into the value, right? And that we will add what that we have marked, we will mark it as 1, so that we have at that position value. Okay, so what it is doing, actually at this node position we are doing minus this one, means we are using that mark, right? So if that mark is now 1, so we will make on that loop, and we'll check if this is the level we have. Okay, let's see how we'll do that. We'll take adjacency list not have, if adjacency list contains key, right? Not contains key at what? At the given node, right? So if this node doesn't contains, then what we will do? We will return our what? Our node count, right? We will return, right? Finally, what we will do this? We will go to now its all neighbors, right? And for that, all its neighbor, what we'll do, we'll take neighbors, you say, or child node, you can say, right? We'll go to its all neighbor or child node, that is our adjacent list dot get, and we'll pass our node. Correct. Now we'll go if child node equal to parent, means we have already visited, and so that we will do what, continue. If that is not the case, means we have to traverse, right? So what I will do, we'll call our DFS utility method, this one again here, recursively we'll call. This time node will change, right? This is our child, node, right? And this is our what, parent node is our now node, right? And adjacency, will pass the adjacency, level will remain same, answer will remain same, right? But when this moves, right, we have to store somewhere, right? And that is nothing but our what, array of child we have to count all its child. What we will to do, we have to count all its child, count all child, we can say, right? All its child we have to count. Then we have to add the frequency of the child node in the parent frequency array. How we'll do that? That we have maintained earlier. We will do for, we'll start I equal to what, 0, and then we'll go I is less than 26 and I plus plus. So in this way we will traverse our array and at the count this array we have already marked, which have all the levels, right? So what we'll do here, we will do I, and this is plus equal to, and we'll update our initial count. Already we have given what, 1. Now we'll do update its value by its child count. Whatever the count will come, we'll update from here, right? And that's all, I think. Yeah, we are done. One more thing, I think. Yeah, we have to return some value. Sorry. So for that, what we have to do, we will go to, after coming to this loop, right? This is the for loop, right? What we should do, we should always add on the answer, right? That we have not did. Answer at what, at the node. For all the node, we have to update the all node count, right? All node count we have, and levels array we have. From the levels array, add that node, right? What we will do, the previously we used to do, we'll do minus that we have added initial value. Now it's, you have the initial value, we have add that value, and now that is updated, so answer will contain the correct count. Then what we have to do, we will return all node count. Let me compile and then we'll summarize this problem. So ages, I think I've given miss ages will come to one array, sorry. Node A, add is, a spelling may be mistake, like this. Here is a mistake, I have to, sorry. Now plus operator at what position? No, int P, I have given correct one. Bad operand for binary operator plus equal to, at which position we have taken? Line 32. Let's go to line 32. Plus equal to count. Yeah, all count I plus equal to, this would work. Sorry, this is array we have taken, we have to pass I. I'm sorry. Yeah, this would work. So what I have did here, right? We have maintain our adjacency list, then we have moved to all the its edges to initialize our adjacency list, and we have maintained our, we have completed our adjacency list. Now after that we have taken the answer of nodes, right? And that we will do after what we will do, that we will uh, extract all the uh, alphabets from a string and make into array. After that we'll do DFS. We are passing what, index node 0, and then -1 is the parent. We'll start from, actually we are starting from node 0, and then we are going to each parent, its parent is -1. We don't have the root node, we don't have the parent, so that we are doing there. And similarly after that we will traverse its child, all the child's node, and will count its value. So for the counting we will take this value, and whatever the value we have here, and that will update our, it's all the adjacency. Okay, and then it will return the data. So it will update your count. Let me submit this program. It's very easy DFS problem is this one. So it's working fine. Thank you so much guys. Please continue this video and write the you can say complexity. If you're not aware with, you can watch my previous video so that you will understand the DFS very well. Thank you so much.